Hello and welcome back to the final part of our series of preparing 3D models for STK. Up to this point, we've added articulations, attach points, and model pointing to our drone model that we've been working with. And we've also seen a few ways to leverage those features in STK. Now, the final feature we're going to be talking about today is solar panels. So you can define any mesh on your 3D model as a solar panel, and then in STK, any mesh that has been defined as a solar panel will then be recognized for power generation when using the solar panel tool. So we're going to start in Visual Studio Code again, and we're going to add the solar panel definition. This time, not in the articulations block, because the solar panel is quite literally just metadata. There's no articulations involved with the solar panels. Any rotations of solar panels are going to be defined via the rotation articulations and the model pointing. But to actually define pieces of our mesh, so the literal geometry as a solar panel, we have to create an entire new block. And this is going to be outside of even the AGI articulations block. That's called AGI STK metadata. And we're going to make a new line. I'm going to hit Control and space. And under metadata, there's two main options. The one that we're interested in is, of course, going to be this solar panel groups option here. The no obscuration nodes option we're not going to cover in this series of videos, but just as a brief description, it will just allow you to define pieces of your mesh as not being obscuring if you were leveraging the as-el mask tool in the body masking files or the obscuration tool. For today's video, we're interested in the solar panel groups option. So we're going to add a new line, and there is going to be three main blocks of code here, the first of which will be the name block. And much like articulations, this is where you're literally just defining the name of the solar panel group. So when you open up STK and you see different solar panel groups as your options, what you're defining as your name here is what you'll see. And I should clarify for this example, obviously the drone doesn't have actual solar panels on it. This is just for representative demonstration purposes, and we're going to define the propellers as solar panels just so that we can see what's going on. So I'm going to call this props for propellers. We're going to add a new line. The second thing that we have to define is the efficiency. So this is literally the efficiency of your solar panels. That's going to determine the power output when we use the solar panel tool. I'm just going to call this something like, let's say, 25%. I should say this is a percentage value. New line, and the final thing we need to define is model nodes. And again, much like articulations, this is where we're literally defining what part of our the mesh of our 3D object that is going to be recognized as a solar panel. So we want to come back into Blender and we want to see what the mesh is called that we're interested in. So we have all these different blades names, much like when we made the propeller articulation. And I'm just going to add all those into this block. And to speed things up a little, I'm just going to copy and paste directly from the articulations that we made for these propellers. Great. So now we've defined all of our propellers as solar panels. I'm going to inject this information into the GLTF like we've seen a few times now. So I'm going to save this file, go to the GLTF, hit the F1 key. I'm going to type in inject, and I'm going to choose this inject gmdf into GLTF command. I'm going to save this file. I'm going to right-click on the GLTF, and I'm going to come down to GLTF, export to GLB, and save this new GLB file. Now, before we hop into SDK, I do want to discuss one other little thing to be aware of. So a lot of times I'll run into a situation where my solar panel, or at least the part of the solar panel that's actually generating power, is not a completely separate object in the 3D model itself. So the propellers that we've chosen to look at right now are completely separate objects. I can move them independent of the entire drone model. Now, where this will come into play is a lot of times the solar panel object will have the faces that are actually generating power be the same object as, say, the back of the solar panel, or maybe even the rod that is connecting the solar panel to the satellite's bus. So the important thing to note here is that these objects in Visual Studio Code that we're defining in model nodes is going to take the entire object. So if we're interested in only certain faces that are generating power, we're going to have to go into our 3D model, rip those faces out of the object that they're currently in, and make them their own separate object. So let me demonstrate that with our drone model here. And what I'm going to do is, we're just, for demonstration's sake, we're going to say that this little screen that's displaying the flight time of the drone is actually also a solar panel. And you can see right now that the screen is a part of this larger object that is holding the actual, what we're going to call the solar panel. So what I need to do is, in Blender, I'm going to come select this object. I'm going to enter edit mode, which I can do with the drop down up here in the upper left, or I can press the tab key. And then ensuring that I'm in face selection mode, so I can either hit 3 on the number row, or I can, again, up in the upper left here, I can choose this far right option for face select. And what I'm going to do is I'm going to select the faces that I want to generate power. You can either drag and click to box select, or if you're at like a weird angle and you need to make multiple selections, you can just click, or you can drag and click, and I'm selecting 2 faces, and then if I hit shift, it'll save the selection I've already made and add to it. So now I have all of those faces selected that I want to generate power. I'm going to hit the P key, and I'm going to choose separate by selection. Now, if I exit edit mode and I go back into object mode with the tab key, we can see that this screen here that we're working with is now a completely separate object from the housing that it was in. So now that we've ripped those faces out and we've made this screen its own object, now we can come back into Visual Studio Code and define that object as a solar panel, and it will generate power in SDK. So what I'm going to do is I'm actually going to make an entire new solar panel group just for demonstration purposes. So we have to make a new curly brackets so that we are defining a brand new group of solar panels. I'm going to hit Control Space, name. We're going to call this solar panel screen, since we were looking at the screen of the flight time recorder. Give it an efficiency value, and this is where, if you have different solar panels that have different efficiency values, we can change the efficiency value here. So let's say that this screen's efficiency value is 50%. And finally, model nodes again, and we have to go back into Blender and see what this new mesh is called. So we see it's called flight hour recorder underscore LP.001. So we'll type flight hour recorder. It can autofill .001. And now that we've defined our 2 solar panel groups, I'm going to save this file. I'm going to do the injection process again. And with our solar panel groups now defined and all that information saved in the GLB, we're going to go to SDK, and we're going to take a look at the solar panel tool. So the solar panel tool can be accessed by right-clicking on your object of interest and going to aircraft in this case. But if you have a different type of SDK object, this drop down right here would maybe say satellite or ground vehicle or facility or whatever SDK object you're currently working with, in this case an aircraft. And then under this drop down, you're going to select solar panel. And you can see right away in the solar panel view window, every object on our 3D model that we've defined as a solar panel is this red color, versus every object that is not defined as a solar panel is just this flat black color. And you can see as we animate our scenario, you'll see, let me speed this up real quick, you'll see that the drone moves along with the animation, so you can see how the solar panels are changing and being obscured potentially by other pieces of the object, or sorry, other pieces of the 3D model. In the actual solar panel tool itself, we can select obscuring objects. So maybe you have, if we had, for instance, two drones flying closely together, maybe we would want to say one drone is obscuring the other one. And then you can select which solar panel groups you're interested in. So maybe I don't care about the propellers at all, and I only care about the power that that little screen is generating. I can select screen and hit apply. And now when we do our computation, only the screen will generate power. I'm going to select both for demonstration purposes, and let's do the computation and see what the analysis looks like. So I'm going to set the time step to 30 seconds. The interval that we're interested in is just the entire length of this specific scenario we're looking at. And I'll hit apply and finally compute. And when I do that, we're going to see the scenario play out over here in the solar panel view window. It was pretty quick, but if you have a slower time step, you would see it play out in closer to real time. And finally, we can use this generate button to see our analysis. So you can choose what kind of analysis you're interested in, whether it's the power output, or perhaps you're interested in the area, the visible area of the solar panels. We're just going to look at the power, and you can generate a report or you can generate a graph. So I'm going to hit the generate button. And there you go. This maybe not the most interesting analysis in the world, since there's not too much going on in this scenario, but you can see our power generation for each of our solar panel groups over the duration of the scenario. So you can see, even though we set the efficiency of the screen to be a higher value, since the area of it was incredibly tiny, it's generating almost no power, versus the quote-unquote propeller solar panel is generating way more power. And that's all there is to solar panels, and that's all there is to our 3D video series on how to prepare 3D models for SDK. If there was something that wasn't covered in this video series, you can always reach out to support@agi.com, and we'll be more than happy to answer your questions or provide any clarifications. I've been your host, Lucas, and hope you have a wonderful day.